As we've mentioned many times, an exponent is just shorthand notation for repeated multiplication, and here are some examples. 2 to the first power means 2 times itself 1 time. 2 to the second power means 2 times itself 2 times. 2 to the third power means 2 times itself 3 times, and 2 to the fourth means 2 times itself 4 times, and so on. However, in all of these cases, we're moving forward with larger exponent numbers. But what happens if we go backwards to smaller numbers? Therefore, in this video, we will explore smaller numbers, including 0 and negative numbers. Let's start with negative numbers. The negative exponent rule states a negative exponent is equivalent to the reciprocal of the base raised to the positive exponent. That's a lot, so let's explain with a couple of examples. First, if you have a base raised to a negative exponent, you move it to the denominator of a fraction and change the sign of the exponent to positive. Therefore, 2 to the negative third power changes to 1 over 2 to the third power. Then, on the other hand, if the base is in the denominator with a negative exponent, you move it to the numerator and change the sign of the exponent to positive. So, 1 over 2 to the negative third power changes to 2 to the third power. But why does this work? Let's go back to the beginning of the video when we saw 2 to the first power through 2 to the fourth power. As we move forward to bigger numbers, we continue to multiply by 2 each time. However, if we start at 2 to the fourth power and move backwards, we can start dividing by 2 each time. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2, which brings us to 2 to the first power. Now, let's keep going to the 0 power and then negative powers. Dividing by 2 gets us to 1. More on that in a moment. Then, 1 divided by 2 is 1/2. Boom! Guess what just happened? When we hit a negative exponent, all of a sudden the answer became a fraction. This is why we saw 2 to the negative third power change to 1 over 2 to the third power earlier. The negative exponents get us into the fraction zone. And if we go a couple more times, we get 1/4 and 1/8. Those are the same as 1 over 2 to the second power and 1 over 2 to the third power. It's just what the definition said. Make the negative exponent positive and put it in the denominator. Now, keeping the same graphic, let's explore the 0 exponent. If you notice, when we reached an exponent of 0, our answer was 1. This is actually a rule. Anything raised to the 0 power is 1. For example, 2 to the 0 is 1, 1 million to the 0 is 1, this big expression equals 1, and so on. Here's why that works. If you notice from earlier when we were dividing by 2 each time, when we got to 0, what really happened was 2 was divided by itself. 2 divided by 2. This is an old rule from elementary school. Any number divided by itself is always 1. They always represent one whole. The 0 exponent always is in the spot where the number is divided by itself. Therefore, it will always equal 1 no matter what number we're working with.